It's gonna trip me up.
Do
So I just have to keep doing them.
Repeat again and again.
That's what I tell you. Like
Yeah.
the physics part, I get it. When
It's
we
the
start doing the
algebra.
calculations,
Algebra part.
I'm not strong in algebra, so
Yeah.
that's what makes physics so hard for me.
Just practice. There's no easier way to master algebra. But you need to. For example, with this question, you can go over again later. Maybe do the same calculation to see if you can get the right
I am.
answer. And then number 8. This one is so if you read the question, I don't know if it's easy for you to understand. There are 4 identical particles. The mass is 0.24 kilogram each of them. They are placed at these places of a rectangle and held in those positions by 4 lat rods. So there's no weight. In the frame there's no weight. And here is 2. Here is 3 meter. So if there is an axis here passing the center of mass of the body and is parallel to the shorter side, it will be like this, right? And it will be rotated like this. Okay. So they ask you to calculate the moment of inertia for this whole system. Okay. For this one, what the 1, 2, 3.
So wouldn't it be 4m times r squared? Wouldn't it be the moment of inertia?
Yeah. So for each one will be m times r squared, right? For 4 of them will be 4 times m r squared. So it's 4 times 0.24. That is m. What is r?
So it's 3.
Here is 3. It's a diameter.
Oh, okay.
So the r will be 1.5.
Mm.
Okay. 1.5 squared. And then if you calculate that, will be 2.16. The answer will be B. Okay.
Just explain why is it 1.5?
So it's rotating like this. What is r? R is from the particle to the axis, to the center. So it's from this particle to the center. It's in the middle, the axis.
Oh, okay.
So
It's split.
yeah. So this will be the diameter,
Okay.
the whole side. You can only use half of it as the r.
Okay.
That's number 8. Then number 9. The rigid object shown is rotate about an axis. So here, perpendicular to this bar, here is the axis. Okay, they are rotating like this. They are rotating like this. Okay. 2m and 2m. Here is L over 2, here is L, here is L. Okay? And the total kinetic energy of the object as it rotates is equal to, the energy is equal to 1.4. If N is 1.3 kilogram and L is 0.5 meter, what is angular velocity of the object? So the first thing we need to do is to calculate the moment of inertia for the whole system, right? So for this m, for everything it will be m times r squared. Okay? For this one will be m times l squared, because here is l. From this object to the center, to the axis, right? And then this one will be the same thing. For this one is 2m times L over 2 squared plus this one is the same thing, 2m times L over 2 squared. So you understand here. And if you calculate, that will be 3 L squared. Okay? And then the energy, there's no rolling involved because it's just rotate of the system, right? The energy will be equal to this. That's
How did you get 3 ml squared?
Let's do it. You understand here?
Yeah,
So here will be 2 ml squared.
right.
Here will be 2m plus, right? 2m. L over 2 squared will be L squared over 4.
Okay.
And then this 2 is the same, right?
Mm-hmm.
Times 2. Times 2. Understand? Here? And 2 over 4. Cancel.
Oh, okay.
So you got m times L squared. Here you have 2m L squared.
Okay.
So it will be 3m L squared.
I get it.
Okay. And then this equation, you know,
Yeah.
we just need to plug in the numbers. The energy is 1.4. And I will just calculate is 3 ml is 3 times L squared. The angular velocity we don't know. So that's what they asked you. They asked us, what is this? Right? So calculate this. You got times 3. M is 1.3. L is 0.5 times omega squared. And then this is easier because you just need to calculate this number and use this to divide this number. And then square root will be the angular velocity, right? And then you calculate it, will be 1.69. So the answer will be C, 1.7.